In this lesson, we are going to learn how to predict products of double replacement reactions. So just to refresh your memory, a double replacement reaction is when you have a compound AB, which is soluble, dissolved in water, and you react it with compound CD, also aqueous, dissolved in water. What will happen is when these compounds are dissolved in water, they will dissociate or separate into their individual ions. So this cation goes into the water with this anion, and this cation goes into the water with this anion. But when they are dissolved in water, they are 4 individual ions swimming around, and so new combinations can be made. Cation A might be now be associated with anion D, and we will write it in that order. The cation is always first in the formula, and the other cation will find its way to the other anion, B. So we would still keep C first because it is the cation, and D would be written second. Now, one of these products may not be soluble in water. And if that is the case, it will precipitate out. Let's say A and D do not want to stay dissolved in water. So they will link up. They will link up, and they will not stay dissolved in water. So we will not write aqueous. We will write S because it forms a solid where there was no solid before. And we say that this is the precipitate. It precipitates out. The other combination will always be aqueous. So sometimes you can have a double replacement reaction where everything stays dissolved. There are some that this will not precipitate out, but very often you will find that there will be some new combination of ions that cannot stay dissolved. And we indicate that with an S for solid, and you would see it form as a precipitate in the solution. So what the goal of this lesson is if I give you these reactants, your job is to predict the chemical formulas of the products. So that's the goal for today. So we're going to start by doing this with just word equations. So we see here that we have aluminum iodide plus lead 2 nitrate. So we're going to write the word products on the product side. So aluminum, remember, think of each one of these compounds as 2 parts, a cation and an anion, a cation and an anion. So we're going to take aluminum, and now we're going to match it with nitrate. Right? We took these 2, and we're going to link those together. Now we're going to put a plus sign, and the other 2 we're going to have those write those together. But we're not going to write it as iodide lead. We always have to write the cation first. So this becomes lead, Roman numeral 2, iodide. That's it. That's how you do the word equation for these. So let's keep going down, trying a few more examples. Silver nitrate plus potassium phosphate. So let's put silver together with phosphate. So we have silver phosphate as one of our products, plus the other product is going to be potassium nitrate. Another example, copper 2 bromide and aluminum chloride. So we're going to get copper 2 bromide plus, nope, not thinking, copper 2 chloride, right, copper 2 and chloride, and aluminum bromide. All right, let's take a look at the last 2 examples. Barium chloride reacting with sodium sulfate. So our first product is going to be barium sulfate plus sodium chloride. So notice that when we write these formulas, there's not a plus sign in the middle of the compound name. The plus sign separates the names of the two different compounds. Last example here, lithium carbonate and cobalt 2 chloride. This is going to rearrange to lithium chloride plus cobalt 2 carbonate. All right, so this is important. If you're understanding the name switch, this is going to be super helpful when we now take it up a level and we do this with chemical formulas instead. So let's take a look at the next piece of this. The first thing we are going to do is predict the products of the following reactions by writing their correct chemical formulas after the arrow. And then it says to balance the equations, add coefficients only after correctly writing the chemical formulas for the products. So first and foremost, we have to predict the products. So here's how I'm going to suggest you do it. Name these chemical formulas first, right? So I'm going to call this is sodium, I'm going to do it underneath, sodium and OH. If you don't know what OH is, you're going to want to have access to polyatomic ion chart, reference table E. And we're going to see that OH is something called hydroxide. So this is sodium hydroxide. This right here, I'm going to put this one up above. This one is calcium bromide. Okay. So now that we know the names of the two reactants we're starting with, we can see that one of the products that we're going to get, sodium hydroxide plus calcium bromide, we're going to end up with sodium bromide. And I'm going to write it up here, sodium bromide plus calcium hydroxide. Okay, so now that we know the names of our products, okay, let's leave ourselves some room here. I didn't do this very thoughtfully, right? We want to make sure that we're protecting our chemical equation here. So we're doing kind of scratch work above it and below it. So sodium bromide. To figure out the formula of sodium bromide, you are going to need your reference tables and specifically your periodic table, right? Sodium is Na with a +1. Bromine is Br with a -1, right? So Na +1, Br -1. Because those charges are equal and opposite of each other, this formula just becomes NaBr. I'm going to bring down that plus sign, and now I'm going to do the chemical formula for calcium hydroxide. Calcium is Ca +2, right? Ca +2, I'm getting that from the periodic table. Hydroxide, we saw that earlier. It is OH with a -1 charge. So when we see this, we're going to have to drop and swap. This formula becomes CaOH in parentheses 2. We're going to put blanks in front of those, and we're going to come back and leave this balancing for another day. We're going to practice first just writing the chemical formulas for the products. All right, our next reaction, let's name it. This is silver, this is nitrate. I'm going to put this up above. This is silver nitrate. Okay. All right, this one's a little trickier. Fe can either be a +2 or a +3, so we're going to have to put a Roman numeral on that. This is going to have to be iron something. And then CrO4, we're going to go to reference table E. I should have had a second one out here to have it more commonly available, right? CrO4 with a -2 charge is chromate. So this is chromate. And we know that the chromate was CrO4 with a -2. This whole thing is a -2. So that means this iron has to be a +2. So this is iron, Roman numeral 2, chromate. All right, that seems like a lot of work, but that hard work pays off now when we go to predict the products. Okay, so we're going to put silver and chromate together. So silver, chromate. And we're going to put iron 2 and nitrate together. Iron, Roman numeral 2, nitrate. Okay. So now that we have the names, I'm going to do some scratch work down here to figure out what the formulas are, right? Silver, when we look it up on the periodic table, is a +1. Chromate, we already looked it up before, it's a CrO4 -2. So this formula becomes Ag2CrO4. I'm going to bring down that plus sign. Iron 2 is an Fe +2. Nitrate is NO3 with a -1. So this formula becomes FeNO3 2. All right, we're going to put blank lines in front of those, and then we're going to come back and balance those at a later point in time. We're going to focus on just writing chemical formulas. All right, let's start ahead, look ahead by just like protecting the space where we're going to write our chemical formulas. We're going to write the names up above. So this is silver nitrate. Potassium. K is potassium. S all by itself is sulfide. This is potassium sulfide. Okay, let's do the name switch. We're going to end up with silver sulfide plus potassium nitrate. Okay, silver. I'm going to do the scratch work. Silver is Ag +2. Sulfide is S -2. Drop and swap, we get Ag2S. Bring down the plus sign. Potassium is K +1. Nitrate from the reference table E is NO3 -1. Drop and swap, this is KNO3. Put some blank spaces before those compounds, and we will come back and balance that later. 2 more reactions to try to predict the products for. All right, so what do we have here? Let's go ahead and protect the line where we're going to write our chemical equation. Let's write names up above here. NH4 is something called ammonium. PO4 from reference table E is phosphate. Plus, this is lithium hydroxide. Let's do the name switch. We're going to have ammonium hydroxide plus lithium phosphate. Okay, let's do the scratch work. From reference table E, ammonium is NH4 with a +1 charge. Hydroxide, also from reference table E, is OH -1. Together, this is NH4. We need one of each. NH4, OH. One of these, NH4, OH. Bring down that plus sign. Scratch work. Lithium, Li +1. Phosphate, PO4, -3. Drop and swap. This becomes Li3, PO4. Put blank spaces in front so we can balance that later. And we have one more equation to predict properties of. Let's go. Let's draw a protected space where we're going to write our chemical equation. And let's do the name game. CaCl2 is calcium chloride. Na2CO3, this is sodium. CO3 is carbonate. You can find that on reference table E. Doing the name switch, we're going to get calcium carbonate plus sodium chloride. All right, let's do some scratch work to figure out the formula for calcium carbonate. Calcium, Ca, charge is a +2. Carbonate, from reference table E, CO3 -2, -2. +2 -2, those cancel out. This formula becomes CaCO3. Bring down your plus sign. And then sodium chloride, I bet you know this one, but Na +1, Cl -1, this is just NaCl. Okay, we're going to go ahead and put blank spaces in front of those, And now that we've gotten some good practice predicting the products of a double replacement reaction, let's go back up and try to balance these. Okay. All right, so we're going to work our way left to right. We're going to do this one element at a time, and we can keep double checking to make sure that everything is balanced. To start, I see sodium. I have one on the left. I have one on the right. On the left side, I have OH. I have one of these hydroxides on the left side of the equation, but over here on the right side, I have two of these hydroxides. So I'm going to put a 2 in front of the NaOH, but now I realize that that just upset the balance for sodium. So let's go back and fix that. I'm going to put a 2 in front of the NaBr, so that's going to balance my sodiums. That hasn't changed my oxygens or hydrogens. They're still 2 apiece. And let's see, I'm going to go back to the left. I'm going to keep working my way to the right. The next element I see is calcium. There's one here. And on the right side, there's one. So that seems to be okay. There's one last element that I have not inspected yet, and that is bromine. I see 2 on the left side, and I see 2 on the right side. So this is a 1, this is a 1, and this equation is balanced. Let's take a look at the second equation. The first element I see is silver. I see 1 silver on the left. I see 2 silvers on the right. I'm going to go back here and put a 2 in front of the AgNO3. That gives me 2 of these nitrate groups, 2 of these NO3s on the left side. And when I go to the right side, I'm going to see 2 NO3s. So those elements, both nitrogen and oxygens, within those nitrates are okay. Now I know that there's some other oxygens over here, but they're bound within the chromate. So let's see what happens. Let's check everything and see what happens. So the next element, as I move left to right, is Fe, iron. There's one here on the left, and there's one here on the right, so that's good. Now, chromate, CrO4, let's treat that as a unit. There is one of these CrO4 chromate units, and there is one of these CrO4 units on the right. So this equation is balanced with the equations 2, 1, 1, 1. All right, let's take a look at the third equation. Silvers on the left, one of them. On the right, there's 2. So we're going to put a 2 in front of the AgNO3. That gives me 2 nitrate groups, 2 NO3s, 2 NO3s. But over on the right side, I have only one of these NO3s because this is currently a 1. So I'm going to have to change that to a 2 to give myself 2 of these nitrates. So I'm going to keep working my way left to right. The next element I see is potassiums. There are 2 on the left. But there are now 2 on the right, so that fixed itself. And the last element I have to look at is sulfur. 1 on the left, 1 on the right. The coefficients here are 2, 1, 1, 2. All right, the fourth equation, let's balance it. And what you have now noticed is in these double replacement reactions, we are treating polyatomic ions as one distinct unit. It's so much easier if we can just think about this ammonium, this NH4 grouping. There are 3 of them. So let's look on the right side. In this equation, there is only 1 of these NH4 groups. So we're going to fix that by putting a 3 in front of it, instead of breaking that apart and treating the nitrogen and hydrogen separately. Okay, so polyatomic ions and double replacement reactions stick together, so treat them as units. So let's do that for this phosphate, PO4. There is 1 of those phosphates here. On the right side, there is 1 PO4 group, so phosphates are good. The next element I see is lithium. There is 1 on the left, but there are 3 on the right. So I have to put a 3 in front of the LiOH to fix the lithiums. Lastly, I have to look at OH. Remember, OH is this hydroxide. There are 3 hydroxides on the left. There are now 3 hydroxides on the right. So this equation is balanced at 1, 3, 3, 1. All right, last equation to balance. We have, on the left, 1 calcium. On the right, 1 calcium. On the left, going back to I always go left to right. The next element I see is chlorine. There are 2 chlorines on the left. On the right, there's only 1, so I'm going to fix that by putting a 2 in front of the NaCl. So calciums are good, chlorines are good. Next element I see is sodiums. There are 2 on the left, but I have just corrected that when I put the 2 in front of the NaCl. So sodiums are 2 apiece on both sides. CO3, that is carbonate. There is 1 carbonate in this formula. There is 1 carbonate in this formula. So this equation is balanced at 1, 1, 1, 2. All right, in this video lesson, you have learned first how to predict products of double replacement reactions just by name swapping, making sure that you keep the cation name written first and the anion name written second. Cation, anion, and you just switch the names. This is helpful because if you know the names of the products, you can then use your ionic naming or ionic formula writing skills, look up the charges of the cation and the anion from the periodic table, from reference table E, drop and swap, and then you have your correctly written formulas. Once you have your correctly written formulas, then you can go back and balance the equations by adjusting the coefficients. All right, that's it for this video lesson. We'll see you back in the classroom.